Hi, do you know how to make multimodal embedding spaces? With that, I mean how you can make models that embed images and text together in such a way where images and text covering the same semantic content, it should end up in the same place in the embedding space. This particular type of embeddings, multimodal embeddings, are very useful to have in this VLM scenario where you have large language models that can also read in, for example, audio, as in Gemini, or images and video, as we've discussed already. Unfortunately, it turns out that you cannot just take your favorite computer vision model like YOLO and ResNet to do this. And I think it's most likely because these models have not been incentivized to make an embedding space internally that sort of communicates in the same way as we do, namely by language. One particular type of model that has been incentivized to do that is a model called CLIP. And so what CLIP has been trained to do is take images and their image captions and embed both of them individually, and then do it in such a way that if you embed an image and its caption, it has roughly the same embedding. While if you take an image and a caption from another image and embed those, they will have different images. Oh, sorry, different embeddings. Now, this uh, is very useful because you can, after you have trained a model in this way, you have sort of, by having this alignment between text and images, you have sort of taught the model to communicate via text, or at least have an embedding space that is similar to how we would put text together magically. It's just a part of the training dynamics. Who knows why? It's very magical, but it seems to work. And so what you do afterwards is you strip away the part that does text embeddings, and you only use the image embedding part, and you plug it back into your vision language model. And then with one additional little layer here, which is typically called a projection layer, which is something you need to learn, then you can learn how to translate these embeddings into embeddings that the LLM will also understand. I kind of like to think about it as having two embedding spaces that are very similar, except from like a shift and a scale. So you kind of need to just put them into place where they are similar. So it's a very small layer. This one is very cheap to train, like as compared to these two. And with the clip paper, they managed to train this model by scraping 400 million images and their captions from the internet and training the model on that. There's actually a very interesting paper out this week from Hugging Face that says that concepts that are um, sort of abundant on the internet work really well with this image embedder, but concepts that are not that abundant, they will not work, and they basically require exponentially more data from the internet to scale like the accuracy of the models linearly. So that's not good. We'll need to find a way to fine tune them, and I think that's probably possible. I'll cover that in a later video. I think it's a really interesting topic. Um, yeah, so that's basically the idea. Now, there's a much there's more sort of technical details to be said about this. You basically construct this similarity matrix where every image embedding is incentivized to align with its own text embedding, or its caption embedding, and it's incentivized to not match everything else. It's done by cross entropy on the rows and the columns of this similarity matrix between images and captions within a training batch. I have created a notebook where that actually happens in code, where you can also sort of visualize how the embeddings they change over time. Here we can see how every pair of image and caption starts at a randomly initialized neural network. It starts uh, way apart from each other, but then over time, what will happen is that similar, like images and their captions, they will get closer and closer in the embedding space. And that's really what we want. And then this projection I mentioned before will take that embedding space and translate it into something that the LLM understands. If you want to like play around with the notebook, I'll share the link in the comments. Otherwise, have a good one.